Hey calculus, so what we're going to be doing today, we're going to talk about the mean value theorem for integrals. We're going to finish up those notes. So first thing we left off on was that basically the mean value theorem for calculus, not for calculus, for integrals, basically says that, hey, if there is an area under the curve, this yellow area, the yellow area here is represented by an integral. So the area under the curve from A to B is the same thing as the integral from A to B of f of x dx. What the mean value theorem for integrals basically says is provided that the function is continuous, there has to be a point C on the curve such that f of c times b minus a, which is right here, is equal to the integral from a to b of f of x dx. So what this is basically saying is that there is some blue rectangle out there such that if I take the blue rectangle from a to b and I multiply the distance from a to b times the height of the rectangle, that area will be the exact same area as the yellow area under the curve. So basically, if I think about what the mean value theorem for derivatives says, it says that, hey, provided that a function is differentiable and continuous, the slope of the tangent line has to equal the slope of the secant line at some place on the graph. This one just provided that the function is continuous. Provided that the function is continuous, I know that the area under the curve is the same thing as the area of some rectangle under the curve that has height f of c. Okay, let's keep going. So we just did a quick practice for mean value theorem with integrals. The point of this practice is that it took us a really, really long time. What we can really conclude from that last problem is this, that to quickly find the height f of c, all we need to do is take 1 over b minus a of the integral from a to b of f of x dx. That is what is equal to, we call the average value. The average value is literally just the height of a rectangle that has the same area under the curve as the actual area under the curve. So the height of the rectangle, if I just take the integral and I multiply it by 1 over b minus a, that is the average value. Okay, so we did a practice problem here. It says find the average value from 1 to 4 if f of x is equal to 3x squared minus 2x. So all we're going to do is use fundamental theorem of calculus down here, which means I'm going to take the antiderivative evaluated at 4 minus the antiderivative evaluated at 1, and I'm going to multiply it all by b minus a, 1 over b minus a, times the integral. So 1 over b minus a is going to be 1/3. So what we're saying here is that the height of a rectangle that has the same area under the curve as the actual area under the curve is 16, which is pretty interesting, and that's basically average value. We're going to talk about the applications of average value in a little bit and what it actually means with respect to a situation. So what we did next is we practiced some problems that might appear in the AP test. First one says, if f of x is equal to x cubed has an average value of 12 in the interval 0 to k, then what must k equal? Well, I know that average value is equal to 1 over b minus a times the integral from a to b of f of x dx. Well, I know some things. I know that a is 0. I know that b is k. And I know f of x, and I also know what the actual average value is. So I'm going to set the average value equation equal to 12. 1 over b minus a is going to be 1 over k, and we're going to say take the integral from 0 to k of x cubed dx. So if I just use fundamental theorem of calculus, what I should get is that the integral of x cubed is x to the 4th divided by 4, evaluated from 0 to k. So really, everything is almost in terms of k here. We just need to evaluate it at k. So what we're going to do is use fundamental theorem of calculus again, evaluate at the upper limit minus the lower limit. I'm going to plug in k and then subtract from 0. Just using a little bit of algebra here, some k's are going to cancel, so I get k cubed over 4 is equal to 12. K cubed is equal to 48, so whatever the cube root of 48 is, which is letter D here. All right, let's move on to the next question. So the next question is a free response question. Basically gives us a bunch of points. It says the velocity in feet per second of a high-speed rail train is positive between 0 and 60. The velocities at time t are given by ordered pairs. First thing we want to do is estimate the acceleration. Well, if I'm given velocity and I want to estimate acceleration, I just need to find basically the slope of the velocity. So what I'm going to do is I'm going to estimate. I'm going to find 2 points that are really close to 25 and average them, or find the slope. So I just found the slope using those 2 points, and I got 3.5 feet per second squared. So it says use units of measure. This would probably be worth 2 points. 3.5 would be 1. Feet per second squared would be 1 because that is the units for acceleration. Next one, it says use a left Riemann sum with 3 intervals of equal length to approximate the area under the curve between 20 and 50. That's the integral from 20 to 50 of d of t. Use correct units and explain the meaning of the integral in context. First thing you want to do is figure out your delta x. Delta x is equal to b minus a over n. Well, b minus a over n in this instance is going to be 50 minus 20 over 3, which is going to be 10. All I need to do now is add up 3 rectangles starting on the, where does it say? Left. So starting on the left means I'm going to start on the leftmost value, which is 20, and then move 3 rectangles after that. So we're going to end on 40. We're going to have 10 times f of 20 plus 10 times f of 30 plus 10 times f of 40, which is going to end up being 1,400. Not 1,400, 4,100. All right, the next one. This is the last one we left off on. It says evaluate the integral from 20 to 50 of v prime of t. This is classic fundamental theorem of calculus. If I take the integral of a derivative, I should get the same thing out. So the integral of a derivative, if I took the integral of v prime of t, then what I should just get out is v of t. If I evaluate v of t using the fundamental theorem of calculus, I'm going to evaluate it from the upper value to the lower value, or the upper bound to the lower bound. We can get v of 50 minus v of 20, which is 95 minus 105, which is equal to 90 feet per second. And it says, hey, explain the meaning of the integral in this context. We kind of left off on that, but basically the meaning of the integral in this context is saying that basically from the time t is equal to 20 to the time t is equal to 50, I have a net gain of 90 feet per second in velocity. Just remember that the area under the curve is a net gain. It's basically saying, hey, here's the net change between 2 time intervals. I know I really went fast on that, but that's pretty much all we did today. And we do have a web assign due tomorrow over 4-4. Let me know if you have any questions, and that is it.